My name is Johan Kuylenstierna. So I work for the Stockholm Environment Institute, and as Nathan said, I'm also a member of the CCAC Scientific Advisory Panel. And what I'm going to do is to try and introduce you to the concepts and the approach that we've been developing, and where the Science Advisory Panel has been developing in interaction with countries as part of the coalition, some of the concepts that we're going to talk about here. So, so what is this concept and the approach? Well, essentially, the multiple benefits pathway is a way of looking at the mitigation opportunities to limit the rate of temperature rise in the near term, which is a particular focus for the Climate to Clean Air Coalition, but also in the long term. And also, importantly, to consider the impacts on health, on ecosystems, on forests, growth, etc. And this is done through an integrated approach, looking at short-lived climate pollutant strategies, carbon dioxide and air quality strategies. So this is the important thing about this approach is that it's supported by an analytical framework. And you'll be hearing from two countries who have been using the concepts here within the analytical framework to understand the consequences of the mitigation for multiple benefits. So the analytical framework estimates emission scenarios and the benefits of action. We place those within the framework of the Paris targets and emphasize the benefits to the countries that take the action. So appealing to national development priorities. And we've been also developing tools that can help countries quantify the benefits of action. And the whole idea of this is that by highlighting and quantifying some of these benefits, we can increase ambition. But why is it relevant to be thinking about these now? Well, clearly, we know that there are millions of people dying early every year, and that's just the tip of the iceberg in terms of the health impacts of air pollution. And the sources of short-lived climate pollutants, greenhouse gases, we know that they're also the sources of air pollutants. So the mitigation affects human health. But also there's an impact on crops, not just through climate change, but also through the impacts of tropospheric ozone, which is something which I'm going to pick up on here, where there are some significant gains that can be made through mitigation. And also, all of this can be put into the context of trying to understand how it's going to achieve different socioeconomic development goals of countries. And clearly, all of this is also important now to look at ways of reducing the rate of warming. We all know that warming's happening now, it's speeding up. But we can take action to reduce that rate of warming and help us to achieve our goals. Now, this diagram, it was produced in a UNEP and WMO assessment in 2011, and it was this chart, partially, which led to the interest of all of these countries that have now joined the CCAC by pointing out opportunities in terms of mitigation and its impact on warming. And so we have the temperature path that we've already taken. But what's important to look at here is if you look at the purple line, you have the baseline scenario. But there where it says methane and black carbon measures, so these are measures which were carefully chosen in this assessment, and if they were widely implemented around the world, they have the ability to reduce the warming in the near term, and the estimate through this modelling was that it could be about 0.5 degree by 2040, 2050, and it could halve the rate of warming over that time period. So this was really pointing out that these substances, which are short-lived in the atmosphere, have a warming impact. If you take them out of the atmosphere, if you avoid the emission, you get a rapid benefit in terms of warming. So, but what's new is that we've within the scientific advisory panel, we've reframed this narrative because now we have the Paris temperature targets. So, it's really about looking at an integrated strategy of limiting near-term warming by looking at all of the substances, the trajectories that countries are taking in terms of emissions, and understanding the impact of this on near-term warming on the way to the Paris targets. So, the Paris Agreement also explicitly links climate and then also the attainment of near-term sustainable development goals, and also poverty eradication. Now, the narrative which we started off in this UNEP-WMO assessment, which has been carried through as an important part of the Climate Clean Air Coalition, is that the measures, the actions taken to reduce the rate of warming over the near term are also affecting some of the major sources of air pollution. And you're actually talking about avoiding millions of deaths every year once these measures are implemented. So this is part of the Sustainable Development agenda, and is one reason why many countries have found the CCAC message important. But also, we're looking at agricultural yields. So, as well as climate impact on agriculture, tropospheric ozone is also affecting agricultural yields. So methane is one of the precursors of tropospheric ozone, and abating methane will reduce ozone pollution, and then the sources of incomplete combustion, which give rise to black carbon, also emit precursors of tropospheric ozone, and mitigating those sources will also lead to reduced ozone. The reduced ozone will avoid some of these yield reductions, which can be significant, as well as improving human health, because ozone is another important pollutant affecting human health. So we have this sort of legacy. It's been going for a few years now, but we've been developing the concepts. And last year, the Scientific Advisory Panel put out this paper looking at the importance of the pathways towards the Paris targets. And we came up with a narrative which we think is quite important. So essentially what we're saying is that we have the long-term targets from the Paris Agreement, and there are different pathways that we can take to achieve those. So here we have this blue line. It's aiming to have a low rate of temperature increase in the near term going towards the Paris targets. But you could also achieve the Paris targets by not achieving a temperature rise decrease, or reducing the rate of increase in the near term, and still achieve the targets. And if you were to undertake mitigation of some of these short-lived climate forcing elements, you could do that late and still achieve the targets. Now, this has implications. And if we have late mitigation of these substances, we would compromise the attainment of many sustainable development goals due to particularly air pollution and also cumulative warming. So there's a big difference between the lower blue line, which is the one that we are saying is the line we should aim for, not surprisingly, and the other lines. There's a big difference in cumulative warming. And why is that important? Well, I'm sure you hardly need to be told. It will make a big difference to the amount of tundra melting. It'll make a big difference to mountain glaciers. It'll make a big difference to the melting of ice caps, and also to the amount of warming in the sea. And here's just one example. This is looking at different RCPs at the degree of tundra melting over the century under different temperature pathways. So there's a lot to be gained by limiting the amount of cumulative warming. But also, climate changes over the next decades are going to be especially problematic for the poorest populations who are particularly vulnerable to the climate changes. And so it's important both to reduce the rate of warming in the near term and avoid many of the impacts, and this will clearly have an interaction with the amount of adaptation, speed of adaptation required. So if we continue to follow the high rate of emissions, then we're consigning, as well as the impact on climate, we're consigning millions of people to premature deaths over this time period. We're also losing millions of tons of crop yield, tens of millions of tons each year. So there's a lot to be gained by moving down to the lower trajectory, and then it's a better chance of achieving many of the societal goals as well as the climate goals. So the important thing about this approach is that it's not just a concept, but we're applying it, and we're applying it with countries. You'll be hearing of 2 applications, 2 very different countries later on. And so this pathway approach has been, or is being practically applied by countries who are interested in this narrative. And you can do it for a country, and that's what we're going to hear about, but you can do it for a city or a region. And essentially it's about demonstrating the multiple benefits of mitigation to slow the rate of warming, limit air pollution impacts, and help achieve national goals. And in order to help this, we've been developing some tools. So there is one tool developed by the Scientific Advisory Panel where if you have the right emission estimates, you can estimate temperature change in annual time steps, global temperature change, also change in the Arctic. The same calculations are included in this tool, which has been developed by the Stockholm Environment Institute, based on the LEAP tool, where we've added benefits calculations. So the first thing you need to do in undertaking this analysis, and then Daniel will be showing results of having applied this in Ghana, is you need to estimate your emissions and mitigation scenarios for all of the substances affecting warming, as well as all of the substances affecting PM2.5 concentrations and ozone concentrations. We then link this with the results of an atmospheric transport and chemistry model. So we have a simplified relationship between the emissions and the concentrations of PM2.5 and of tropospheric ozone. And then we link that to concentration response functions for human health, in this case premature mortality. We estimate the change in global warming in annual time steps, and estimate the change in crop yield due to ozone concentrations for 4 staple crops. And so this is a kind of a practical test. We're working with 12 countries at the moment, although more countries will start to use this, and some of them are quite advanced, and Daniel will be showing results of this. And so essentially, and I'm not going to dwell on these results because Daniel's going to show them later, but what you can do with this tool is you can say, if you have scenarios of different ambition, what is the reduction of warming committed to the globe from emissions from a country? And then what is the reduction, what is the avoided number of deaths from the strategy? And what are the impacts on crop yields from changes in ozone concentrations? So that's a taster for what you will be hearing from Daniel. And so just to the conclusions. So essentially this multiple benefits pathway approach is an integrated approach. So you can look at all of the mitigation strategies in a country. You can look at the CO2 mitigation, the SLCP mitigation, air pollution mitigation, and understand, by putting it together, understand relative influence of the different strategies on the multiple benefits. So the multiple benefits being change in net global temperature from the emissions from that country, and also the benefits in terms of changes in air pollution. And the important thing to mention is that local benefits can help drive ambition, but if countries want to undertake such an analysis, you have to have an understanding of the emissions of all of the relevant substances in tons, not just as in such CO2 equivalents, because you need the physical numbers to put into the analysis. So thank you very much.